Hey guys, in this video we're going to learn how to identify the properties and use the properties of squares, rectangles, and rhombuses. Okay, so we've discussed the properties of quadrilaterals and parallelograms, and we have a little family tree going on regarding how the rhombuses and rectangles and squares relate to parallelograms and how parallelograms relate to quadrilaterals. They're all related in some way. Okay, so then if we think about it, the quadrilateral is the most general name for all of these figures below, and all you have to do, or all you have to have if you want to be a quadrilateral, is to be a four-sided polygon. So you have to have four sides and it has to be a polygon. Now, a more specific type of quadrilateral is a parallelogram, and in a parallelogram you have to have four sides, and also both pairs of opposite sides have to be congruent for it to be a parallelogram. Also, opposite angles are congruent, and also opposite sides are parallel. Okay, so then those are specific qualities of a quadrilateral that will identify it as identify the figure as a parallelogram. Okay, we can also say that a parallelogram has diagonals that bisect each other, so when they intersect they cut each segment in half. And also consecutive angles, so angles right next to each other, are supplementary. So we have quadrilaterals, so most basic general name for a four-sided figure, and then we get really specific with parallelograms because all these properties exist in the parallelogram. Now, even more specific, we can get more specific with the names of parallelograms with the three below. We have rhombus, rectangle, and squares, which are all parallelograms, but then they also have their own specific qualities that make them a rhombus, rectangle, or square. So then the rhombus has all of these properties in it, but if we want to call that parallelogram a rhombus, well, on top of all these blue properties, a rhombus has all sides that are congruent. So every single side is the same measure, and then also the diagonals are perpendicular. So that little upside down capital T represents perpendicularity. So then when the diagonals intersect each other, there are four 90-degree angles that are created. Okay, and then another property for a rhombus to be, or for a parallelogram to be considered a rhombus, is that not only the diagonals are perpendicular, they also bisect the opposite angles. So the vertex angles are just the four angles that are inside the rhombus, and when we draw the diagonal, they actually cut the angles in half, and we'll talk about that later in the video. Now, branching off of the parallelograms is also a rectangle, and a parallelogram that can be identified as a rectangle, well, that rectangle has to have four right angles, and the diagonals are congruent. So the rectangle has all of these properties: four sides, both pairs of opposite sides are congruent, angles are congruent, opposite sides are parallel, diagonals bisect each other, and consecutive angles are supplementary. And then specifically, the rectangle has four right angles and diagonals are congruent. Okay, so then even more specific, we can go with a parallelogram, is that we have a rhombus and a rectangle, then now we have a square. The square has all of these properties above it. So the square has all the properties of a rhombus, has all the properties of a rectangle, has all the properties of a parallelogram, and then even more specific is that we have all sides are congruent and all angles are right angles. Okay, you can't just have all sides are congruent for it to be square, because then it's a rectangle. Then it's a rhombus. The square has four right angles and four congruent sides. So the best way to think about, like, if you're trying to remember what properties each quadrilateral has, the square is the most specific, and the square has all the properties of a rhombus, has all the properties of a rectangle, has all the properties of a parallelogram. For a rhombus, has all the properties of a parallelogram, and for a rectangle has all the properties of a parallelogram, and the parallelogram is a four-sided figure. So essentially, if you look at it, it's like a little tree of priority, I guess, in terms of what properties that they each have. They're all related in some way or fashion to each other. So for example 1, we have for any rhombus RSTV, decide whether the statement is always or sometimes true. So for angle S, is that congruent to angle V in rhombus RSTV? So let's first draw a rhombus, or a parallelogram, and mark angles S and V. So if it's a rhombus, we know that all sides are congruent. Is it always or sometimes true that angle S is congruent to angle V? Well, we know that a rhombus is a parallelogram, and if you look at angle S is opposite of angle V, so we can say always, because the rhombus is a parallelogram and the rhombus also has opposite sides and angles to be congruent to one another. Now for angle T is congruent to angle V, we can say sometimes. Okay, so angle T and angle V are located right here, so if we mark that, hold on a second, it's only true if we have a square involved. So the angle S and angle V are opposite of each other, so that's always true. But angle T and angle V, they can't be congruent unless it's a square. So a rhombus needs to have 4 congruent sides, which is true. But if we have the consecutive angles to be congruent, then it would have to be a square, because we'd have to have 90 degrees here, 90 degrees here, and all the interior angles of a quadrilateral add up to 360. So then we would not only have 4 congruent sides, but we would have 4 right angles in this quadrilateral. So not any rhombus, but if it's a square, then it's sometimes true. Alright, example 2, classify the special quadrilateral and explain our reasoning. While looking at the diagram, we have a 4-sided figure. One angle marks 70 degrees, so I know that not any of these angles can't be 90 degrees. We just noticed the only information that we have is that it has 4 sides and it has 4 congruent side measurements as well. So the most specific name I can give it is a rhombus, because all sides are congruent. Alright, so specific properties of a rhombus we talked about earlier in that tree slide that we had in the beginning. The diagonals of a rhombus. Well, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So let's draw a rhombus really quick. All 4 sides are congruent, and if we draw 2 diagonals, 1, 2, when they intersect, a 90-degree angle is formed. Okay, so that's one property of a rhombus concerning its diagonals. And below, we can say that a parallelogram is a rhombus if and only if each angle is bisected by its diagonals. So this is what I was talking about earlier. When we have our rhombus again, 4 sides are congruent, and we have, let's say, 80 degrees. These are our measurements for our angles, 80, 100, 80, 100. And we draw a diagonal, it'll bisect these angles. So if this is 80 and this is 80, once we draw a diagonal from one end to the other, it'll bisect the angle, which means that now we have 2 40-degree angles on each vertex angle. So if we draw another diagonal, instead of 100, we have 2 50-degree angles here and 2 50-degree angles here. So diagonals bisect each other. And diagonals bisect the opposite angles of each other. Now the next one says diagonals of a parallelogram. Cross it off and write down rectangle. And the diagonals of a rectangle state that if a parallelogram is a rectangle if and only if its diagonals are congruent. So what that looks like is if we have a rectangle with 4 right angles, which is the only property that we need to identify the quadrilateral as a rectangle, the diagonals are congruent. So DB is congruent to AC. When they intersect, they bisect each other, so then you'll see that you have 4 congruent segments after they intersect with one another. Okay, so then AC is congruent to BD. Alright, so now we have to list we have to sketch rectangle EFGH and list everything that we know about it. Alright, so let's draw a rectangle EFGH. And from the slide earlier, I took the properties from our tree, and these are the properties of our parallelograms, and these are our properties of our rectangles. So we know that a rectangle has all the properties of a parallelogram. So we listed everything that we know about it, so let's talk about how it applies. Rectangle EFGH has both pairs of opposite sides are congruent, so let's mark that in our diagram. So 2 tick marks indicate that the sides are congruent, and the 1 tick mark means that these sides are congruent. So they're different measurements, but we know that EH is congruent to FG and EF is congruent to HG. We also say that opposite angles are congruent, but then specifically about the angles of a rectangle, there are 4 90-degree angles. So let's mark that. We know that opposite sides are parallel because it's a parallelogram, so we would mark the 2 arrowheads across from each other, and the 4, I guess, total arrowheads marking that EF is parallel to HG. The diagonals bisect each other, as well as the fact that they are congruent. So we can show that the 2 diagonals are shown here, and when they intersect, they have bisected each other, and they are congruent. So then the 1 tick mark indicates that they are all congruent to one another, the 4 segments that it's created, and also shows you that EG is congruent to HF. And then finally, consecutive angles are supplementary. If we know that that's 90 degrees, angle G is 90 degrees, 90 plus 90 equals 180 degrees. Okay, so those are the properties of a square, rectangle, and a rhombus, and they are all part of the parallelogram family, which all fall under the quadrilateral family. Definitely make sure that you ask questions the next day. We'll talk about those properties in class. Have a good day.